In this session, we are going to continue exercise 21.1. In the last class, we have learned how to find out the area of the shaded portion. Alright. Now, as you can see that we have a trigonometric function, so make sure that before starting this question, all of your calculators are in radian mode. And make it a practice whenever you see a trigonometric function in calculus, so make sure that your calculators are in radian mode. Diagram shows part of the curve y is equals to sine 2x plus pi over 3. Find the x coordinate of the point where the curve cuts the x-axis. Alright. So we know that when your curve cuts the x-axis, it means the value of y coordinate is 0, right? So we are doing the same. We need to place the value of y 0 here and find out the value of x. So 2x plus pi over 3. Alright, when you shift sign here, so it will be sine inverse of 0 equals to 2x plus pi over 3. If you do remember, so that is basically the concept of trigonometry, and we need to find out the alpha base angle. So if we curve sine, right, so sine is 0 at 3 places. At 0 sine is 0, at 90 sine is 0, and at 360 sine is 0. So in terms of pi, 90 is what? 90 is pi over 2, and 360, that will be 2 pi. Alright. So sorry, it's not pi by 2, sine 0 at 180. Alright, so it's 0, pi and 2 pi. We need to find out the value of x for a part, right? So sine inverse 0 has 3 values, that means 0, pi and 2 pi, but after 0 the first value we are getting, it's pi. So we need to find with the value of pi, it's 2x plus pi over 3, right? So pi minus pi over 3 equals to 2x, taking LCM, it's 3 pi minus pi equals to 2x, right? 3 pi minus pi, it's 2 pi over 3 equals to 2x, and 2 and 2 cancel. So x is equals to pi over 3, that is your a coordinate. The coordinates will be pi over 3 comma 0. Alright, so once you have the value of part A, that is pi by 3 comma 0, it says the area of the shaded region. So the function we have is y equals to sine 2x plus pi over 3. Alright, now you need to integrate and place the limits here, but before that you need to give it a try first. So what you need to do, first note down the solution and then complete it by yourself first, and for this complete part you have a time of 3 minutes. So start. Alright, so first you are going to integrate that function. First, the integral of sine is minus cos, but do we have the derivative of the angle? Right now we don't have, but we need to multiply and divide it by 2. Right? Now the function is ready to integrate. The integral of sine is minus cos 2x plus pi over 3, and this 2, it will be 1 divided by 2 as it is. Right? And the limits we have is from 0 to pi over 3. So now it is equals to minus 1 over 2 cos 2, the value of x is pi over 3 plus pi over 3. That is my upper limit, minus cos 2, lower limit is 0 plus pi over 3. Now I need to solve this expression here. So minus 1 upon 2 cos 2 pi over 3. Now pi over 3 is what? Pi over 3 is 60, right? So from your calculator you can find out cos pi over 3, and that will be minus 0.5. Minus 0.5 is 1 upon 2. 5 upon 2 minus cos 0, it's 1, minus plus minus pi over 3. So pi over 3 and pi over 3 cancel. It's minus 1 upon 2 outside the bracket. Inside the bracket we have minus 1 upon 2 minus 1. If you take LCM, you will get minus 3 over 2, and it's minus 1 over 2. So when you multiply, it will be 3 divided by 4. Alright, and that is your answer for the area part. Alright, so in this question, the new thing that we have learned is about how to use the trigonometry to find out the coordinates of a specific point, right? So make sure that we have a good concept of trigonometry, how to find the value of alpha and theta. In this scenario, we have sine inverse of 0. There are 3 possible answers, and we are going to pick the first one because we are in the first value, right? Let's suppose we have another point here. So for that point, we are going to take the value of 2 pi. Alright, moving on towards the next question. Question number 7 from the same exercise. Alright, diagram shows part of the curve y equals to e to the power minus x. Find in terms of A the area of the shaded region, right? So you have the value A here, and you need to find the area of the shaded region. So first give it a try. Time is 2 minutes, and then I will explain. So start. Alright class, so we have y equals to e to the power minus x. If we are going to integrate the function, so the derivative of the power, right? The integral of exponential is exponential only when you have the derivative of the power with it, right? The derivative of power is minus 1, so we are going to multiply with minus 1 and minus 1. Now the derivative is present, so function is ready to integrate. It's minus e to the power minus x, right? And the limits, it says from 0 to 8. So now it's minus, and if I reciprocate it, so it will be 1 upon e to the power x, and we have from 0 to 8, right? So now it will be minus 1 upon e to the power a, upper limit minus lower limit, and we know that every number with 0 power leads to 1, so it's minus 1 upon e to the power a minus plus, it's 1. Alright, and further I can say that it is equals to 1 minus this e to the power a, it will be e to the power minus a, that is your area. Alright, so that is your first part, and after that, given that the area of the shaded region is 0.5, now you have the value of area, it's 0.5, find the value of a. So we have the value of area after integration, it's 1 minus e to the power minus a, and which is equals to 0.5, the value is given. Now we need to simplify this equation to find out the value of a. So firstly, I will positive this function exponential, so I will shift it on the right side, it will be e to the power minus a, and it's 1 minus 0.5. 1 minus 0.5, it's 0.5 is equals to 1 divided by e to the power a, right? Or I can say that e to the power a is 1 divided by 0.5. Alright. Further, e to the power a. Now 1 divided by 0.5, it's 2. Alright. Now we need to find out the value of a here, and the reciprocal of exponential is ln. So we need to apply ln here because we need to find out the value of a, and whenever we have power in terms of bases, we need to apply logs, so that the property of log is it can express the power as a coefficient, right? So it will be 1 upon 2, ln e power a is equals to ln 2, and then a shift as a coefficient, so it will be a ln e is equals to ln 2, right? Ln e is equals to 1, so a is equals to ln 2, and you can find out the value of ln 2, and that is 0.69, that is your answer. So if you are confused that why we apply log here, so the very simple rule to apply log: when power is in variable, apply log. That is very simple rule to know that when there is a need to apply log, right? Similarly, in this case, we have power in terms of variable. That is why we need to apply log here. Alright, so now you need to note down the solution. You need to apply, you need to note down the second part. Alright, so you have a time of 2 minutes to note down in your copy, and then I will start the next question. So start. Alright, done. I hope that all of you are getting the concept that how to apply limits and how to integrate. Integration part we have already done. Class, it's question number 8. It says that diagram shows part of the curve y equals to 1 plus x square, and of the line x equals to a, as you can see on the diagram as well. Find in terms of a the area of the shaded region A. Right. So for the first part, until we need to find the area of the shaded region A in terms of a, that is very much similar to all the questions we have attempted previously. So you need to integrate the function y and then place the limits from 0 till the point A here, right? I hope that all of you can do it easily, because the next part in which we need to find out the area of B, that is different, and we haven't attempted any questions as this one, right? So the part B I will explain in detail, but before that we need to find out the area in terms of A for part A, and for that part you have a time of 3 minutes to start, to begin. Alright, so when you are going to integrate the function, it will be the integral of 1 is x, and the integral of x square, it's x cube, divided by 3, and we have the limits from 0 to a. So when you place the value, it's a plus a cube divided by 3, and that is your area A of the shaded part. Alright, now for part B, before explaining this question, let me give you some example here. If you focus on this example, the reason that it is different from the other ones because the range lies on the y-axis but not on the x-axis, right? So in this question we have lower and upper limit on the y-axis, not the x-axis. So what method do we need to opt to solve such type of questions? Whenever we have such type of questions in which the limits are on the y-axis, so firstly from your equation you need to make x the subject. So already if I need to integrate, so it will be x square equals to y divided by 4, and x equals to y divided by 4 with the root sign. You can say that x equals to y power 1 upon 2 divided by 2. Alright, So whenever we have limits on the y-axis, so make sure x is the subject, and now we need to integrate the function. So 1 upon 2 as it is. The integral of y, simply we need to add 1 in the power. So 1 upon 2 plus 1, it's 3 upon 2 divided by whole power 3 upon 2. If you simplify it more, so that will be 3 divided by 2 to the 4, 5 to the power 3 upon 2, and then we need to apply the limits from 1 to 4. Alright, so the main thing that I want to highlight here is when we have limits on the y-axis, make sure that x is the subject of your equation. Right, now you need to compare this scenario with your part B, portion B here, right? Now if you observe that portion B, it also lies on the y-axis, right? But the value, what is the value at this point, right? So you have the equation of the curve y equals to 1 plus x square, and you place the value of a, x value, that is a, so it will be y equals to 1 plus a square at this point, right? So the value here is 1 plus a square, that is my upper limit. So for region B, we have y equals to 1 plus x square. Firstly we need to make x the subject, right? So it will be y minus 1 equals to x square, applying root on both sides. So x is equals to y minus 1 to the power 1 divided by 2. Alright, once you have made x the subject, now we need to integrate the function. So the integral of y minus 1 power 1 upon 2, we need to add 1 in the power. So 1 upon 2 plus 1 is 3 upon 2 divided by 3 upon 2, and we have the limits, that is from 1 to 1 plus a square, right? Now 3 upon 2 as the coefficient, it will be outside the integral sign, and now we have y minus 1 power 3 upon 2 with the limits 1 and 1 plus a square. Now we need to apply the limits here. Alright, so the upper limit is 1 plus a square, so it's 1 plus a square minus 1 power 3 upon 2, upper limit minus lower limit, it's 1 minus 1, that leads to 0. Alright, so it's 2 over 3, 1 plus a square, 1 and 1 cancels, so it's a square to the power 3 divided by 2, right? 2 and 2 cancel. The leftover part is 2 over 3 a power cube, that is my area of region B. Alright, so that part is new because we haven't learned to find out the shaded region of such type of shapes in which we have limits on the y-axis. So when you have limits on the y-axis, the first step is you need to make x the subject, right? X the subject like we have done here, and then assign the values on the y. Now in the question it says you need to find the value of a, and the shaded region of a and the shaded region of b are equal. Alright, so according to condition, area of a is equals to area of B. Area of A is A plus A cube upon 3 is equals to area of B is 2 over 3 A square. Alright, if I take LCM here, so it's 3A plus A cube over 3 equals to 2 over 3A square. 3 and 3 cancels. So now the equation we have, it's A cube minus 2a square plus 3a equals to 0. Alright, we can take a common here, so it's a square minus 2a plus 3 is equals to 0. Alright, and now it's a equals to 0, and the next equation is a square minus 2a plus 3 equals to 0. Now that is the quadratic equation. So the middle term is a square minus 3a plus 3 equals to 0. a minus 3 plus 1. Alright, so there is one mistake here, that it's 2 upon 3 a cube, and I have written 2 upon 3 a square, so I need to correct it. Alright, it's not a square, it's a cube. 2 upon 3 a cube, that is my area B. Alright, so now it will be 3a plus a cube equals to 2a cube. Alright, and 2a cube minus a cube on the right side, it will be a cube equals to 3a. Right? If I shift 3 on the right side, it will be a cube minus 3a equals to 0. We can take a common here, so it's a square minus 3 equals to 0. If you have a equals to 0 and a square minus 3 equals to 0, a square equals to 3, apply a root on both sides. So a equals to 1.732, that is the value of a. Alright, and since the value of a must be positive, that is why we are not taking the negative value from the under root sign. Alright class, so it's a lengthy question and it's a different type of questions in which we need to find out the region on the y-axis, right? So first we need to write down the solution in your copy, and I have zoomed out a little bit so it will be convenient for you to note down the solution, and you have a time of 5 minutes to note it down, and then I will start the next one. Alright class, I hope that all of you had noted it down, and to just summarize the last minute important things is, whenever we have curved region in such a way that its area lies on the y-axis, so we need to do x should be the subject of your equation, and then you need to integrate your question, and after that you need to apply limits, but this time limits in terms of y, alright, because we are dealing on the y-axis. So I think that it is quite enough for today class. Inshallah, in next class we are going to continue exercise 21.1. Make sure that you guys are practicing it, because this exercise is quite important. And as a homework, what you need to do, you need to try question number 5 from the same exercise. Alright, give it a try, and I expect and I hope that all of you can do it easily. Alright class, we'll see you in next class. Take care and Allah Hafiz.